Hi, I'm Yannis Roussos, the product manager of the database group, and I'd like to take you through what we're planning to achieve in GitLab 14.10, which is scheduled to be released on April 22nd of 2022. As a quick recap of what we are doing, the core mission of the database group is to build the application code, the tools and frameworks that allow every GitLab feature to interact with the database in the most reliable and performant way possible. We also build the tools and product features that allow any GitLab team member to efficiently develop code that interacts with the database, test against production-grade datasets, and make informed, data-driven decisions before shipping any update to the GitLab product. So let me take you through our top priorities for 14.10. The first one is batch background migrations. I have already provided a few in-depth presentations of this new framework in past Kickoff videos. So if you are interested in more details, please check the links that I'm providing in the description of this video. But as a quick recap, background migrations is the way for us that we run asynchronously in the background jobs that execute very large data updates. And I'm talking about millions or hundreds of millions of records updated. And the batch background migrations is a new framework that we are building from the ground up with a focus on reliability, self-monitoring, and auto-tuning. And we anticipate that this will be a major step forward for the stability and availability of GitLab instances of any size, while making most background data operations complete considerably faster in most cases. So we have a lot more information in the related epic. Our work in 14.10 is driving us towards the general availability of the batch background migrations framework. We are already working with a few groups internally that use the batch background migrations for very large, difficult migrations. We even had a small incident yesterday in GitLab.com related to write-ahead log replication, where at the moment we had a batch background migration running, and because it was a batch background migration, the SREs on call were able to pause the migration, let the system recover, and then restart the migration without causing any problems and without a hiccup. So in 14.10, driving towards the general availability, very quickly. So first of all, support for multiple databases. This is something we're working for the full 14.9. This is almost ready. It will be shipped very early in 14.10, maybe in a few days. And then we are going to work on a few last core updates, like for example, updating our scheduling and auto-tuning algorithm to be able to figure out background jobs that fail, how they fail, if they error out or they time out. And if they time out, which means that the batch size may be too large, be able to split them in smaller chunks and execute them in smaller jobs. Similarly, add the ability to disable the auto-tuning algorithm so that we can limit very sensitive, very delicate background jobs that we don't want to change their batch size. We can limit them to whatever we set them during scheduling. Of course, our developer documentation, which is very important for the general availability of the framework, and finally, add additional optimizations to our batch optimizer so that we can support more use cases of data operations, like partial updates by adding a custom batch strategy, etc. Our second top priority for 14.10 is implementing a throttling mechanism for large data changes. So in this case, we are our worst enemy. So we can go too fast, and going too fast can cause problems to the production system. You can go and update millions of records in a minute, and that can cause a system to start feeling it and having multiple issues. So the idea here is to build a mechanism that will monitor the health of the production database and respond to it by lowering the rate of updates, throttling the updates, or even pausing them. And this is very important for us. This is the last missing puzzle on top of what I just discussed for batch background migrations. That's why we are going to implement this mechanism. We're going to introduce it as part of the auto-tuning layer of the batch background migrations. And the idea there is that we are going to have monitoring in real time of the production system and various mechanisms for monitoring various signals that will tell us if there is a problem with the production system, and either lower the batch sizes and the rate of updates, or even completely stop a batch background migration, wait for the system to recover, and then restart without requiring any manual intervention. Our first step in 40.10 will be to identify those signals. So what are we going to measure? So is it about rate of updates? Is it about dead tuples? Other problems we can see on indexes or on the heap, or whether there are maintenance operations like auto vacuum running over a table. All those signals, we are going to use them in order to make those decisions in later steps and finally throttle those operations. Our third top priority is the automated database testing using thin clones. In general, with this is a project that is fully running internally in GitLab. This is an amazing capability we have. We are shifting left our ability to preemptively find database-related regressions and performance issues by testing all database updates against a production clone of GitLab.com's database. So this is amazing. Any update that we make right now automatically in a CI pipeline is executed and tested against our production system. And we have already completed the coverage. We have covered regular migrations and post migrations. Those are migrations that run after the deployment, the code deployment in no downtime updates. And the next step, which we have started working on already on 40.9 and we have completed in 40.9 at the first step of it, is supported background migrations. So background migrations, as I already discussed, supporting them is not trivial because they are meant to be run for long periods of time. So you have a background migration that will update millions, hundreds of millions, a billion records, and it's meant to be run for hours or even days. How do you test it in 10 minutes in a CI pipeline? And this is the purpose of this initiative, to find ways to statistically or other ways cherry pick jobs on various intervals and test them in a few minutes, let's say 10, 20 minutes in a CI pipeline, and make sure that the background migration runs. In 49.9, we have already completed support for regular background migration, our existing background migrations. And in 40.10, we are going to add support for batch background migrations, testing batch background migrations. And then we're going to update the way we return results on the MR to the developers, to the GitLab developers. And finally, add another step of testing that will allow us to estimate how much time batch background migrations will run. Because there is the problem that you may define, you may block the auto-tuning and cap it with a max batch size. And by mistake, set it to a very low value, let's say 1,000 records per 2 minutes. This is very low. And that will result in the migration running for 30 days. And we don't want a migration running in 30 days. So we will add checks about that as well and inform developers that what they are doing maybe feel safe, but it will result in an update that will last for 30 days and they will have to wait for 30 days for it to finish. And finally, adding some of the, as part of all of the other steps, we're also going to add testing the background scheduling logic. This is a very special use case, and we have seen a few problems in the past, because when you schedule a background job, it is created and really created, and you can set it up when it gets out of the queue. So we have had some problems in the past with very specific parameters on background jobs that were passing and could execute without issues on development or testing environments. And when the migration reached production, they could error out for very specific reasons. So this is one more layer of protecting background migrations that are sent to production. Finally, our last top priority is adding the data dictionary. I have also discussed about it in past Kickoff videos. Very quickly, we have more than 400 tables. We want to label them using some metadata so that we can label who the owner is, which group owns the table, and add additional metadata about a description or other data classification metadata. We want to start by labeling tables. This is the most impactful change for us because it will help us very quickly in case of incidents or a bug report to figure out who the owner of the table with the domain-specific knowledge is and address it as fast as possible. So we're going to work on this, add support for labeling tables in 14.10 and add some documentation. So that's it for 14.10. Thank you for watching and talk to you next month.